Good afternoon. My name is Joe Dumit. I'm a professor of anthropology and science and technology studies, as well as the director of the Institute for Social Sciences. It's my privilege to welcome you to our Institute's inaugural Distinguished Lecture, the first in which we hope is a long-running series of fascinating and wide-ranging presentations delivered by eminent scholars in the social sciences. I'd like to first thank those involved in bringing today's event to fruition, including the Department of Political Science, which has provided co-sponsorship and organizational support. Our speaker today is Gary King, the Albert J. Weatherhead III University Professor at Harvard University. King is based in the Department of Government and also serves as the visionary founding director of the Institute for Quantitative Social Sciences, and we've taken up a bunch of his time today finding out how he made that happen. He develops and applies empirical methods in many areas of social science research, focusing on innovations that range from statistical theory to practical application and to big data. That's actual big data, not hype. And King's more than 150 journal articles, 20 open source software packages, and 8 books span most aspects of political methodology, many fields of political science, quantitative methods, and many other scholarly disciplines. His work on legislative redistricting has been used by most American states, by legislators, judges, lawyers, political parties, minority groups, and citizens, as well as by the Supreme Court. Equally influential is his work on inferring individual behavior from aggregate data. His contributions to methods for achieving cross-cultural comparability in survey research have been used in over 80 countries by researchers, governments, and private concerns. And as he presents his lecture today, explaining systematic bias and non-transparency in the U.S. Social Security Administration forecast, please join me in welcoming our inaugural distinguished lecturer, Gary King.
Thanks. Thanks, everybody. Thanks for coming. You should feel free to interrupt or yell out obscenities or whatever it is that you enjoy doing. Thanks for the invitation and for I don't know how many meetings I had today, but it was definitely world's record, and it was really a lot of fun too. So thanks a lot. So this is a paper, actually 2 papers, which I'll explain with my graduate student Konstantin, and actually he is no longer my graduate student, and he's not in charge of lighting either.
We're trying to deal with the flickering. Sorry, it's flickering, and it's not having an easy solution.
We could deal with it by making it flicker more.
You can on or off.
That's right. So Konstantin actually is at Facebook now. Samir is a postdoc of mine, and he's at Dartmouth. And I'm the guy in the middle. So, this comes from research that I did with these folks and or with some others on just some statistical methods, and then some statistical methods as applied to mortality forecasting, and then as applied to some problems in public health. And then we figured out how to apply it to a paper we called The Future of Death in America. And then we applied it to Social Security some years ago, where we came up with a better method of forecasting mortality. And we thought, well, Social Security uses that in ways I'll describe. And we thought that might be interesting. And we found out that the Social Security Administration actually needed $800 million more than it thought it needed. And so that seemed like a valuable thing to tell the world. So we tried to tell people that. And this is sort of follow-up work from that. So what is this stuff? So this comes from, there's just some references if you want to read further, or if you wake up later and you're still interested. So we wrote this paper, Systematic Bias and Non-Transparency in U.S. Social Security Administration Forecasts, and that was in the just published in the Journal of Economic Perspectives. And then published on the same day, actually, is Explaining Systematic Bias and Non-Transparency in U.S. Social Security Administration Forecasts, and that's in Political Analysis. And there's an online appendix with a lot more details, and there's a replication data set for the first paper and a replication data set for the second paper. And in case you haven't been writing all this down, you can get it all from my website, garyking.org/SSA. Okay, so we don't really need to continue here because you could just do the reading, okay? But in any event, let's put this in context, okay? So forecasting turns out to be essential to a lot of the US government. I wasn't really even aware of this when we started doing our project on forecasting, but when we finally got into it, we realized it. So it's really important for Social Security. What is Social Security? It's the single largest United States government program. 37% of all federal outlays go to Social Security, so this is like a big deal. It was $1.3 trillion in 2013. 20% of the elderly would be in poverty if it was not for Social Security. It's enormously popular. Proposals for change are highly controversial, partisan, cross-cutting. It's called the third rail of American politics. You don't touch Social Security. Okay. The way it works in one line is while we're working, we pay into the Social Security Trust Fund. There's actually several of them, so they're called the trust funds, right, which now is composed of $2.7 trillion all set aside. And then the money comes out of the trust fund for when the elderly or disabled people need it. And, and it's very important that the trust fund have enough money in it. If it doesn't have enough money in it, then it goes insolvent and bad stuff happens. So in order to make sure this happens, you have to have forecasts, right? So there's the Social Security Administration demographic forecasts and financial forecasts are made under factual conditions to forecast the solvency of the system. So you have to figure out how long people are going to live, because if they live too long, they're going to draw benefits too much, and so live too long is sort of a strange phrase, but they have to predict how long people are going to live, and you mess up the prediction and you mess up the whole system. It's also used under counterfactual conditions to score policy proposals. So if somebody in American politics wants to change Social Security, how do you know what the impact of that is? Well, they score it, evaluate it, it's called. And so you say, so the Social Security Administration then makes a forecast under those counterfactual conditions. Like if the policy were implemented, what would happen in those circumstances? So these are very important. Other programs also rely on Social Security forecasts. The Medicare and Medicaid trust funds, Congressional Budget Office evaluations, a number of others. These are programs comprising more than 50% of United States government expenditures. So I think I get to study this. You know what I mean? It's like important enough, right? Okay, so however, the forecasts are not so transparent. So who makes the forecasts? In the Social Security Administration, that's SSA, it's the Office of the Chief Actuary. So those are the people that make the forecasts. They're responsible for the forecasts. So who makes forecasts independently of the Office of the Chief Actuary, right? That has enough information to make these forecasts? No one. Okay? So no one has enough information to do that. Who's been able to fully replicate the OCACT, which is the Office of the Chief Actuary? That's their acronym. So who's been able to take their data, follow their procedures, and follow every steps and produce the same numbers? No one. Okay, so nobody. Okay. Some data is shared. They do share some data in very difficult, disorganized, and non-automated formats. And I'll mention also that it's possible to get some data by Freedom of Information Act requests, and it comes in giant wheelbarrows or the electronic equivalent. It's just it's overwhelming rather than the way you might produce a replication data file. Some of it is impossible to share. So they're informal, qualitative methods, committees composed of large numbers of people adjusting huge numbers of adjustable parameters. The methods involved in forecasting Social Security have not changed much since the Social Security Administration started. Much could be shared, but is not with the public or the scientific community or other government agencies, or even we discovered with other parts of the Social Security Administration. So non-transparency and lack of data sharing, we think, violates not only our preferences, because we're scholars, so that's what we do, but it violates emphatic calls from the Social Security Administration's own technical advisory panels, White House executive orders, which recently the executive orders from the White House are they're social science executive orders. Have you seen these things? It's totally awesome. It's thou shalt do more social science research. Right? This is really very nice. Before those, there were executive orders requiring a presumption in favor of openness, data that's accessible, discoverable, and usable by the public. This is not even close in the Social Security Administration. And of course, you know, the data sharing revolution in academia, that has really had a massive effect on whether or not you could get data. 20 years ago, if you were a graduate student and you wanted to ask for somebody else's data, you could ask for someone else's data, and that would basically be the end of the story. Sometimes, occasionally, you would get the data, but people wouldn't even feel guilty. Nowadays, the worst that happens if you ask someone for their data is they feel really guilty and they lie to you. And you know, that's pretty good, okay? Usually you can actually get it now, which is a huge change. This revolution hasn't made it to all parts of government. The standard is not whether this office says they've shared enough, because they'll say sometimes they do, sometimes they can't. The question is whether it's easy enough for others to be able to follow in their footsteps and replicate what they do and make a contribution. That's really the question. And I think it's an enormous missed opportunity for the scientific community, because like we could do all kinds of stuff with those data. But for others to check on Social Security Administration forecasts, and it would be completely free. Like we would work for free, because you know, someone else is paying us, right, to try to improve the single largest United States government program, right? That would be a cool thing to work on, right? Like you can imagine how many of us would do that if we had access to the data. Fortunately, this is really easy to fix, and at some point this will be fixed. Right? At some point, the data will be made available, and this will happen. It's your job to make that sooner. Okay, so let's evaluate Social Security Administration forecasts. How do we do this? So let's take the history of all systematic evaluations of Social Security Administration forecasts, which are presented there on the page right there. Okay, so by the Social Security Administration, there were none. Not a single forecast of the Social Security Administration forecasts. By others, none. Okay, it's really cool, right? Like from a researcher's perspective, like wow, you know, that's sort of surprising. There are a few highly selected numbers presented in speeches by people from the Social Security Administration. They'll say, look at this number from 1984 that we forecast. We did really, really well today. Okay, but it's a systematic comparison, nothing remotely like that. This is a great opportunity for science and policy, however. So the Social Security Administration has been forecasting for so long that they have made forecasts for years that have already occurred, right? So we can actually look and see what the truth is. Most of the time when we do forecasts, we have to just, you know, play tricks on ourselves. Like we set aside some data, we make a forecast, and we see whether we did well. But you know, the fact is, the set-aside stuff, it doesn't matter how we blind ourselves to that. We know that it exists, right? We know those last years in the data set, they actually happened. Like the Earth didn't stop spinning, this program wasn't eliminated. So there's a lot that we actually know about it, right? When you're making a forecast into the genuine future and you don't know about it, there's a lot to be learned here. So here's our methods. These are the methods, the detailed statistical methods we're going to use in this talk. The main one is the method of subtraction. We're going to compare each forecast to the truth and subtract one from the other. That's pretty much what we're going to do. We also conducted, in order to figure out why there is the biases that I'm about to tell you about, we did a lot of qualitative research. We did detailed, sort of semi-structured interviews with participants in every level of the policy making process and the forecasting process. And so I'll tell you about that too. And it's just a really neat story. So here's a preview of the results. Before or around the year 2000, the Social Security Administration, which makes a bunch of different kinds of about people and fertility and mortality and stuff like that, and various kinds of financial indicators of the health of the system, they were approximately unbiased. And by unbiased, I mean the technical statistical sense of unbiased, meaning sometimes it's too high and sometimes it's too low. On average, it's about right. You wouldn't expect that anybody would get it exactly right, okay? But you would expect that it would be unbiased in that statistical sense. So you would hope that anyway. After 2000, we see systematically biased forecasts. All of the forecasts, pretty much, not every one, but almost all of them, are systematically biased. They're all biased, and they're all biased in the same direction. The bias increases over time, and as I said, all in the same direction. What direction, you might ask? in the direction of making the trust funds consistently appear healthier and more solvent than they really are. Okay, so that's the main finding. That's the main empirical finding. How big is the bias? Well, it's larger than almost all almost all of their policy scores. So that means when they're evaluating policies for whether or not they would make a difference, the noise, the error, is actually bigger than the size of the score itself. Okay. Straightforward solutions exist, and I'm going to propose them to you for all the problems discovered. And they're the kinds of things that we learn as social scientists and we understand as social scientists. And if we just apply them to this case, we'll actually learn a ton. So in order to get you into this, in order to get us into this, we need to figure out how they forecast. So let me just give you a feel for the problem here. So here's Social Security Administration methods. They're sort of jerry-rigged and suboptimal and ad hoc. They're not replicable, okay? And they haven't really changed in decades. And it's not just any decades, right? These are the times in which Social Security, statistical methods, data science, has made enormous progress, right? Over the 75-year period, like we've invented survey sampling, randomized experimental design, and all kinds of incredibly sophisticated forecasting methods. So taking advantage of that would be an advantage to the United States government and all those people who live here. But not only data science and statistics, also social psychology has made enormous progress in this time, which is going to come into play here, as I'll explain. So let me give you an example. Here's how they forecast mortality. Okay, so you have to follow this. It's just one page. So first of all, we're going to take 21 age groups, 2 sexes, and 7 causes of death. Multiply those together, and you get 294 things, or cross-sections. And for those 294 cross-sections, we're going to define historical rates of decline. Okay. So how are we going to get these? We're going to run a separate linear regression, an independent linear regression for each one of these 294 cross-classifications of age, sex, and cause. We're going to regress that mortality, and like log mortality, on the explanatory variable of time, just time. So we're not going to use things like how much people smoke, or how much they weigh, or anything like that, right? Or no, basically known risk factors. We're just going to use the linear trend. Okay. Then we're going to have 210, that is 5 age groups, 2 sexes, 3 cause scenarios, and 7 or sometimes 5 causes. Okay. 210. Ultimate annual rates of decline for year t plus 26. Now, if you're wondering, like, well, why the specific numbers? That's the essential arbitrariness of the process. So for 26 years from now, they first choose the ultimate rate of decline, because mortality declines each year usually. Not always, but almost always. Over 350 years in most countries, with some exceptions, they pretty much declines. But the question is how fast it declines. So first step is in 210 separate groups, just defined in the way that I said, for 26 years from now, we define the ultimate rate of decline. Okay. Then how do we do that? We do that by committee. We have a committee of experts. They do it in private, and they come up with those numbers. Okay. Then we define the future annual rates of mortality decline for each of the 294 age groups, that's those. So we define the future ones, assuming constancy within each age group. So there's no change. The biggest risk for dying is like getting older. Okay, So like age is like a pretty important covariate. So, but it's constant within ages. It's only the group that matters. And here's how it works. So for next year and the year after, we take the historical rate, the actual historical rate, or if it turns out to be negative, that is, if mortality is going up, then you only use 75% of the historical rate. These are, the arbitrariness of this is what I'm trying to convey. For year 3, not year 2 and 2 months, okay? For year 3 to year 25, mortality will change linearly from the historical rate to the ultimate rate that you chose previously when you started at the beginning. Okay. In year 26, we fix it at the ultimate rate of decline, and then that stays constant for 50 years. Okay. You see what I'm getting? Okay. And then, but I'm not done. Then we're going to iteratively multiply the 210 or sometimes 150 mortality rates by future annual rates, okay, some across the 7 or sometimes 5 causes within age, sex, cost groups. There's going to be an exam on this, okay? And then a committee in private evaluates the forecasts, adjusts the ultimate rates, that is, goes back and changes the numbers, and repeatedly reruns the entire algorithm until the result is consistent with their views, okay? Which means that the entire algorithm was essentially irrelevant, right? Because you end up consistent with their views. So this is the sort of jerry-rigged system that I'm talking about, okay? You can see that, now, but we're making fun of them. Well, that's probably me making fun of them, but we're making fun of them. But just to be clear, like, 75 years ago, how would you have done this? Okay, it's not entirely clear. Okay, so this is not an insane system. It's just not an updated system. Like, I think we could do better. Like, I think any one of the graduate students I met here today could do substantially better than this. Okay, so what about the data? Let's look at the data and get a sense of what kind of task it would be to forecast better. Okay, so actual mortality time profiles. The vertical axis here is log mortality. This is the conditional probability of death, where this is 5%, this is 50%, or sorry, this is 0.5%, this is 5%, this is 50%. So it's on the log scale, okay? Each one of these beautifully colored lines is dropping over time. The horizontal axis is time. The left is male, the right is female. And each one of these is dropping, okay? And so you can see these incredible patterns. First of all, they're sort of approximately linear. You see how they're all dropping, right? Roughly linearly. You see, however, that they have different slopes. So the oldest ages, it's relatively flat. The younger ages, the mortality decline is faster. Okay? So the public health figured out how to save kids. They're not quite sure how to take 100-year-olds and make them 200-year-olds yet, okay? But we hope they get there, like, in time, okay? There's different variances. So these numbers are, the lines, whatever slope they have, don't vary much. These numbers are very variable, right? They jitter around while they're going down. And then you can see these sort of diagonal ripples. See these? So these are some cohort where something bad happened, and it affects people sort of continuously all the way through. So this is let's see, if we look at these colors, these are maybe, I don't know, 20-year-old, or like these are maybe 20-year-olds, and then the next year they're 21-year-olds, and the next year they're 22-year-olds. So the same cohort jumps lines, right? So it turns out if a cohort, people of a particular age, suffer some kind of event, like they went through a war or there was a particular disease, that cohort, even though they lose people along the way, continues to suffer from that event going forward. And you can see the diagonal ripples through this thing. So that's a sort of complicated thing to analyze. But you could at least imagine developing some kind of statistical methods to analyze it. Like if you'd start off with a bunch of linear regressions, and then you make sure the linear regressions are sort of tied to each other. And then you'd sort of figure out, well, there's higher variance down here than up here. And then you'd, I don't know, do something about these diagonal ripples. Okay. So that's this. Federico Gerosi is a co-author of mine, and we wrote a book called, actually we wrote an article that the shortest article we could write was 250 pages. So it was a book called Demographic Forecasting. We figured out how to analyze data like this. Let's look at the same data over time just to get a better feel for it. I'm sorry, not over time. The previous graph was over time. That's over time. Horizontal axis is time. But if you take the same data, you can plot it by age group. So this is male, this is female. This is age group. Vertical axis is still mortality. Up is bad, down is good. This is log mortality over the ages. So what happens is mortality starts high, it goes down, and then it comes back up. This is a bump for the age of our graduate students when they do stupid things like drive too fast and stuff like drink too much. That bump is literally that. Okay, and then pretty much log mortality keeps going upward. Okay, it looks like the Nike swoosh, right? Okay. And this one is high, for any particular age group, the male one is higher than the female one, right? Okay, such is life. So the patterns, they have this characteristic shape. Actually, not only in the United States, but in like lots of countries around the world, this shape is quite quite common. It's partially linear, like from here on. There's different age time trends. The different colors, by the way, are different years, so you can go through and do it. Aren't the graphs pretty here? Right? You want me to show you the previous one, which was even prettier? Okay. So you can see, basically, analyzing this graph and the data represented in this graph and the same data represented in the previous graph, that's a sort of complicated task, okay? But the patterns are very, very strong. Do you see that? Like we know that 90-year-olds die at a very high rate, and you know what? 85-year-olds die at a lower rate, and 80-year-olds, they die at a lower rate, and 70-year-olds die at a lower rate, right? And it keeps going. So this is a very, very, very strong pattern. It's like, if you take the National Election Study and plot data, you don't get to see data like this, okay? So in a sense, mortality is highly predictable relative to stuff like that, okay? But it's very sophisticated, so that's sort of the setup. Okay, so let's look at the qualitative choices that the Office of the Chief Actuary makes. They basically violate information that we know about the data from lots of research. So we'll take some of their forecasts, and I'll show you some of them. These are qualitative choices, just to be clear. So they're not making forecasts that are automated. They're making qualitative choices of lots and lots and lots of parameters, more than you could put in your head, okay? More than even a committee can keep track of. And as a result of that, if you look through the results, some of them are not going to be consistent with others. Most of them, or many of them, are going to be okay. And anything that humans paid attention to or were able to pay attention to, they'll probably be okay, because these are really smart people that know a lot. But they're all defective because they're human. Right? So because they don't have enough conscious memory because they're human. And so they can't keep 294 parameters in their head and all the relationships between all those parameters. It's just not possible. Okay? So then we knew for sure, because they didn't have any automated methods to help them in things that could be automated, we knew for sure that if we looked through the data, we would be able to find some things that looked completely ridiculous. So here's some examples. This is a time plot, again, this is the death rate vertically and time horizontally. And there's some unrealistic patterns. So this is actual observed data of 80 to 84-year-olds. And in this particular category, which is death due to diabetes, it's going up, 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 up. And if you had to make a forecast from that, what would you expect? So maybe it would go up. But then 5 years later, would you expect it to completely go down? Right? Similarly, for age 85 to 90, it's going up very fast for some reason. And the projection is it's going to go up for a little while, and then whoop, it's going to go down. Now, you could predict, you know what? We think 5 years from now, they're going to discover a cure to diabetes, and this is going to be distributed out to the population gradually, and that's what's going to happen. Believe me, that wasn't the forecast. Okay. You can also look at the differences. So the differences between these is very small, the vertical differences. The differences here are huge. So for some reason in the forecast, they're saying being an 85-year-old is way, way more dangerous than being an 80-year-old. And it is more dangerous than being an 80-year-old. Okay? But the amount of dangerousness is way more here than it was here. Okay? So that's just demographically unreasonable. Okay? So here's another example. Here's 50 to 54-year-olds and 45 to 49-year-olds. We know that it's better to be a 45 to 49-year-old, at least just in terms of mortality, than to be a 50 to 54-year-old. At some point here, the forecasts cross. So that's something that a demographer would look at and would say, not going to happen, right? So this just doesn't make sense, right? Here's another way to look at this. So this is the age profile of mortality, that Nike swoosh. Look at what happens when you turn 50 years old. See how these drop downward? Right? It drops downward, and then it bumps upward. So for some reason, it was, mortality is going up, but then there's something really much better about being 50 to 75, and then it continues, right? So this is just examples of the kind of stuff that, you couldn't be upset with the humans that did this because they're humans, but you could be upset with the people that put the humans in the room in the first place. Okay. So, so let's look at Social Security Administration life expectancy forecasts. These are results. So I'm going to show you the results that we have. So one summary of mortality is life expectancy. So let me just tell you what that is. So life expectancy is not how long you're going to live. because you can't do that. In order to calculate that, we'd have to wait, right? Even if it's not if it's just an observed life expectancy, we would have to wait, on the order of 100 years or something like that until somebody died. So then the data wouldn't be useful anymore, right? So life expectancy, the way the demographers do it, is they look at the rate of death in each of the age groups today, and then they imagine that there was a population of people that ran through, that suffered the risks of all the people, of all the cohorts today, and they keep going it through their whole life, and then that produces a predicted life expectancy. So just so you know, that's how they define life expectancy. But that means life expectancy at today is an observable number. Okay, so we know what that number is. It's not actually a prediction. It's a known number. And then you forecast life expectancy into the future. So what life expectancy is you take the mortality rates today that are observed, the fraction of people that are dying in each of the age cohorts, and there's a whole bunch of them, one for each of the age groups, and you summarize them in one number, which happens to be called life expectancy. Okay, so it's just a convenient way that the demographers came up with doing this. And then you make a forecast of life expectancy. So horizontal axis is time. This is male, and this is female. These are the forecasts minus the truth. So this is life expectancy among people who are 65 years old starting now, and their forecasts between 1 and 5 years into the future. So there's life expectancy today, and then we get to see what life expectancy is going to be in 5 years. Okay, so that's the setup. Okay, forecasts are made in each of these years. There's a trustees report that reports the official forecasts of the Social Security Administration. In 1985, they made a forecast, and then they make a 5-year ahead forecast, and in 1990, we discover how well they did. And so forecast minus truth, 0 would be a perfect prediction. And so here's what happens. The forecasts are around unbiased, again, until about the year 2000 or somewhere in there, right? Sometimes it's too high, sometimes it's too low. And then something bad starts to happen. The forecasts really start to deviate. And remember, these are 1 to 5 year ahead forecasts. It's 1 to 5 because the trustees' reports aren't that consistent about how much they're forecasting and when they forecast. But they knew over here about these errors, but there was no correction. In fact, the errors got worse. They kept getting worse. Okay? Same thing for males and same thing for females. These are done totally separately, so this is not one observation, this is 2. Well, it's actually a whole lot of observations in each category. So that's the point estimates. How about the uncertainty interval? Okay, the uncertainty, the confidence interval coverage. And is a systematic overconfidence since at least 2000. So let me explain what this graph is. On the horizontal axis is time. This is male life expectancy starting at birth, male life expectancy starting at 65. Female at birth, female starting at 65. Horizontal axis is time. Is the time of the trustees' report, the time the forecast is made. Here that they're forecasting is the vertical axis. So that's why it's an upper diagonal figure, because it's to the future. It's a lot easier to forecast into the past. Okay? And then we have green and red. Red means when you forecast, the forecast is outside the confidence interval. Green means you got it inside the confidence interval. So we like to see green. Okay. So here's the patterns. There's a sort of vertical pattern here where you see green to the left and red to the right. Lots of exceptions, of course, but that's basically the pattern. There's red to the right here, and there's green to the left. See that? Okay. So what does that mean? That means the later trustees' reports, because that's the horizontal axis, are overconfident. Right? Their confidence intervals should be wider. I mean, it would have been better if they made forecasts that were not biased, and then they could nail it. But you don't expect that. A scientific prediction is not one that's correct. It's one that is honest, okay, or correctly conveys uncertainty. So clearly, the later trustees' reports are overconfident. For females, pretty much after 2000, they're overconfident. There's a little period in here. But the period in here of overconfidence, the red overconfidence, isn't matched by the males. But after 2000, both males and females for life expectancy at birth and at 65 are all overconfident. Okay. Another thing is, what I would have expected when we calculated this is that we would expect a short-term forecast into the future would be pretty good, but farther into the future wouldn't be as good. So I expected to see horizontal stripes rather than vertical stripes. Right? And I expected to see that in 1990, if you make a forecast, maybe it would be green, 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 red, red, something like that. But it's not that way. You don't see horizontal stripes. The problem here is that the later trustees' reports, the later forecasts of the Social Security Administration, forecasts starting about 2000 were overconfident, in addition to being biased from the previous graph. Okay. So there's a lot of ways of calculating the numbers, or looking at different forecasts, and we've looked at mortality. These are mortality, right? And the previous graph, this was mortality, okay? But that's not the only thing they forecast. They also forecast how much money is going to be in the trust fund. So let's look at that. So one is the trust fund ratio, which is one measure of how the trust fund's doing. Their forecasting errors. So the forecast, it's the forecast minus the truth on the vertical axis. The horizontal axis is everything works great. It's perfect forecast. The horizontal axis is time. This is, again, the year of the trustees report. And as you can see, they're doing pretty well here. And then starting in around 2000, it starts to veer off. Red dots are outside the confidence interval, green are within. So the shaded area is just a summary of the dots there. Okay. So this is a 1 year ahead forecast. And you can see for the 1 year ahead forecast, it's getting worse towards the end. So let's look at a 2 year ahead forecast. 2 year ahead forecast, it gets worse at the end, but worse than the 1 year ahead forecast. And a 3 year ahead forecast, and a 4, and a 5, and a 6, and a 7, and an 8. This is sort of shortening up because we get less data. And a 9, and then that's all of them. And so you can see pretty much for all of them that bad stuff is happening towards the end. The trustees, the forecast by the Social Security Administration since about the year 2000 were biased, overconfident, and increasingly so over time. They didn't correct when they found an error. Okay? Why would that happen? Okay. How come nobody's interrupting me? Do you have any questions? Okay.
Did you look before 1980?
What's happening before 1980?
Yeah, so before, the forecasts were just very sporadic. Like they wouldn't systematically always make forecasts of particular types, and so there would just be like occasional numbers back in the history. Yeah, it wasn't useful to do it in a systematic way because if you sort of make one forecast and you nail it, I made systematic forecasts of the 1992 presidential election, and we got it within 1/10 of a percentage point, and we got every state right. I'm never going to make a presidential forecast again. Okay, right? Because my confidence intervals were a lot bigger than that, so you just don't do it again. But anyway, one-off things you don't want to do. So that was really was not useful. We could shoot. I think they're in a replication data file, so you can see them. They're certainly in the trustees' reports. Okay. Anybody else?
So on the previous slide, it seems like there's a correction like around 1990, at least on some of the larger time frame. And I'm curious, were they getting more accurate and then less?
Yeah, I mean, in other words, like maybe this goes. I mean, I don't know. It's hard to know how to look at these numbers. One way I would look at this is, well, they're too low, they're too high, they're too low, they're too high. That's great, And we can't expect a forecast into the actual genuine future to always nail it. And so if it's too low at some point and too high at another point, that's just wonderful. So that's the way I look at it. But if you know about the economics of it, you might say, well, this was, and this was, so there's a lot of things that affect it. I think it's probably things like that.
Yeah. I don't know quite what the consequences are for the Social Security Administration when they get stuff wrong. But I would imagine if a private life insurance company gets stuff wrong, they go out of business. So I was just curious if you've looked at any of these private life insurance companies to see if A, they're getting it wrong, and if they're getting it wrong in the same way and at the same time that the SSA is getting it wrong.
I would love to, but we have to get them to give us their data, which they haven't. But you're absolutely right. I mean, it would cost them money. So, yeah. Yeah.
Countries that have similar surveys and forecasts?
There are, actually, there are.
And how do they do?
Well, we haven't evaluated them all, but that would be a great follow-up. I'd love to know. And other parts within the U.S. government, we are trying to follow up on some of that. So.
When you're evaluating the quality of the uncertainty estimates, does the SSA provide, when they provide estimates, do they provide their basically standard error? How did you get that number to compare to assess
So
the coverage?
they don't provide formal statistical confidence intervals. They provide high and low estimates. I don't know what those are. We call them uncertainty estimates. They don't say they're 95% confidence intervals. If you read them, they sound like 95% confidence intervals, but you know, I mean, it'd be nice if they both the prediction and the high and the low, they're all guesses. So, you know, at least they do that. You know, that's a good thing. But
So one thing about our department, we've learned that we don't ask questions until the end of the talk. So we've been
Oh, is that
very
right?
polite, but that's what we've honed ourselves in on.
You're
But
too
since-
nice. You're too nice.
Well, I've never been accused of that. Okay,
I'll keep
so-
talking. I'm happy to keep talking.
No, I guess
I just paused.
but I guess the punchline's going to come about 2000. But one way to think about it, it seems like they were remarkably accurate given the utter ad hoc nature of how they did forecasts. I mean, for so many years,
Yeah.
they more or less got it right. So I'm assuming. Well, I know the punchline's coming because I read the article. But the second question.
But they should be asking themselves, why? Why would this happen?
Well, yeah.
That's the idea.
But the second question I was going to hold off, but I guess I'll go ahead and ask now since you're inviting them, is when you had the male versus female plots and you were speculating about why you don't have the horizontal strips on there. It looks like the male error rate occurs much earlier
Yeah.
than the female. So what's going on there?
Yes. I don't know why. I mean, I think they misjudged male versus female, and they didn't correct when they saw that there wasn't a change. So, I can't believe how many questions you guys ask. Okay, I'll continue.
Policy was due to Jeff Gillum.
Is that right? So what about uncertainty estimates for OCACT policy scores? So that's just the policy scores. So who scores Social Security policy proposals? Remember, in order to have a proposal to change Social Security included in the debate in American politics, they have to score it. Okay, so who scores it? OCACT. They're the monopoly supplier for every major proposal, 195 since 1993. No one else can provide these scores. That is, nobody else can provide, that is the only people that, if you have a proposal to change Social Security and you can't get the Office of the Chief Actuary to score your proposal, you're probably not going to get people to discuss it. Okay? The lack of data sharing makes it impossible for anybody else to do a serious evaluation. There are other attempts, but it's not going to be a complete one. They're going to use a lot of OCACT's data and things like that. There are advantages to the system, it's worth mentioning. Both parties can negotiate to one point. Even if the point's wrong, it's nice to give them some reason to negotiate. Being in the office is a lot more exciting, which sounds silly, but actually we want to hire good public servants. And these people get a seat at every table when there's negotiations about Social Security. And so it is probably a lot more fun to be there if they own the access to American politics. Probably you don't want them to have that, but nevertheless. Disadvantages, of course, is the one point the parties are negotiating to might be completely wrong. No one can check to see if it's wrong. It's hard to improve anything in isolation. The scientific community can't contribute. We don't like it, you know, et cetera. The office's uncertainty estimates on the policy scores, none. There's no uncertainty estimates. They just say this is the financial impact or other impact of this policy change. That's it. Presented with 100% certainty, essentially. The actual uncertainty has two components. It has forecasting under factual conditions, right, where you forecast the actual series into the future. And then you're also adding on top of that, you're layering on top of the actual forecast, the change, the intervention into the world to change the policy to see what would happen. So there's two parts to this uncertainty. And so we're going to estimate the actual uncertainty in these policy scores. I'm going to do that for you right now, using just the first of the two. This first one, we know how well they forecast on the basis of the facts, like extending the facts into the future. We don't know how much the forecast would degrade just by the intervention, the policy intervention, right? I mean, we can make assumptions about it, but we don't really know. Okay, so we're going to use number 1 as a lower bound to number 1 plus number 2. And we're going to compute the percentile among all forecast errors where each score appears. Okay, so and then the question we're going to ask is, how many of the policy scores are greater than 5th percentile, i.e. with like alpha less than 0.05. So how many of the policy scores are big enough to be bigger than the errors that they make in forecasting? Everybody see what I'm doing? Okay. These are pretty optimistic assumptions. Our forecasts are 1 to 10 years out, and the policy scores are 10 and 75 years out. We're not including this source of uncertainty, so this is pretty optimistic assumptions. So here's our conclusion. The policy scores are as follows. So here's the percentile of forecast error. You take the distribution of all the forecasts that we've collected, and that's all of these. I'm sorry, we take the distribution of forecasts that we've collected, that's not those. Then we take a policy score, and we figure out at what percentile of error size does it appear. And what we'd like to see is the policy scores be bigger than the errors. Okay? The ones that are bigger than the errors are the ones down here. For 10-year out forecasts, none. Okay? For 75-year out forecasts, there's a few. Okay? And that's for the balance, the trust fund balance, and the cost. So these are 2 of the financial. So most of the policy scores are random noise. Okay? You shouldn't use them. That's like the best numbers they're the only numbers we have, right? But nevertheless, I wouldn't count on this happening in the future if we implement these policies. Okay, so why does all this bias happen? Right? This is what we need to really figure out. Why does this bias happen? All right. So here's the social psychological conditions that make bias at least possible. Okay, so what's bias? Bias are systematic errors regardless of intention or direction. So I'm not talking about like a bunch of hidden Republicans or Democrats or something like that. Okay. So here's what the social psychological literature says. It says bias is likely when humans perform complex tasks with high levels of human discretion, and they're making many decisions, and they get little feedback on whether they made the right choice the last time. Okay? So that's the situation in which the social psychological literature is very clear that bias is going to happen. Right? A human being doesn't know when they may genuinely try to not be biased, but they're not getting feedback on when they made a biased decision, and they have a lot of discretion, and they're making a lot of these decisions. Right? And they're complex tasks. Okay? So, and especially if there's high external pressure or internal motivation to make some decision, and they do it in a group and with few external checks. Okay? So all this stuff leads to bias. This is exactly the Office of the Chief Actuary's situation and procedures. This is exactly the setup here. So the setup for bias, it's just ready-made for bias. Okay? Now, just to be clear, I'm not telling you that these are evil people. They're not. They're trying very hard to be really good public servants. Okay? Qualitative uncertainty estimates are also likely to be biased according to the social psychological literature. Experts are usually overconfident. By the way, the most prominent experts are the most overconfident. Okay? Danny Kahneman says, do not trust anyone, including yourself, to tell you how much you should trust their judgment. Okay? This is Phil Tetlock. The more prominent or central a forecaster, the more overconfident their statements. And as the sole supplier of forecasts, the only group in American politics that controls the access to the debate, it's hard to imagine how anybody could be more central. And it's not the person. So getting people who would try harder or asking these people to try harder would not do anything different. Okay? Replacing one with another usually would have no effect.
So why is this office the sole authority? I mean,
Why is it what?
Why are they allowed to be the sole supplier of forecasts?
Well, they don't define themselves as the sole supplier. Nobody said they shall be the sole supplier. They just don't share enough information, and they don't provide the forecasts in a way that it can all be shared, and then they don't tell you about the ways they could be shared so that other people can make the
It just
forecasts.
seems strange given like the creation of the OMB, the creation of GAO, that Congress and the President have allowed that to continue given the highly political nature of Social Security.
Yes. That's absolutely right. It should change. That's right.
Are you going to tell us what their reaction is to your analysis?
I will tell you, yeah.
So I didn't need to.
So when we wrote our first papers, we shared them with them, working on this over many years actually, and they gave us comments and things like that. And then we sent in our paper to Demography, which is the leading journal in demography, and we sent, but it's not, it's not a public forum, obviously. We sent it to Demography, and it turned out they were the anonymous reviewer. I mentioned this to a few of you, but two of the reviews were, anonymous reviews, like this is okay to change this. The third one was, just what you would expect for an anonymous review, and then the voice changed, and it said, and I would also like to speak. And you say, like, well, who is that person? And then there was a whole review. Like at the bottom of the original review of R2, there was another review. And then at the bottom of that one, there was another one. There were 7 people speaking inside this one human, apparent human. But it was the Social Security Administration. And then when we went back and forth, and they eventually accepted our article, and it was, they said okay to the editor, and it was published. And all that was fine. And then the New York Times decided to print a whole New York Times page with all these beautiful graphics that they did on our work, and then they were not so happy with us. So, they were screaming at the top of their lungs at us. So, but I said, why are you screaming at us? This is exactly the same work as you said was fine. And they said, it's not the same when it's in the New York Times. I said, no, it is the same when it's in the New York Times. But you know what? I'm a political scientist, right? As political scientists, like we understand these things, right? We don't like them, but
But I guess is there any impulse to revisit the policies, rules, and norms and so on?
I don't think that they're going to change like immediately upon seeing this, and I don't think they're going to stand up. I don't think a politician, we're all politicians, right? So I don't think somebody who is essentially a political actor of some sort, or government official, is going to stand up and say, you're right. I think I'm going to make all these changes right now. But on the other hand, do you share, based on your question also, do you seriously think that they're not going to eventually make changes like this? I don't think they're going to do it right now, but I think at some point they will.
Did your qualitative interviews give you any insight into what happened circa 2000?
Yeah, so I'll tell you the story. Like, what is this about? Like, why would this happen? But I'm not quite done with this story about the social psychologists, because you would think that you would take people who are experts. We can combine all these things. Take people who are experts, who are, they may be the most prominent experts, but the ones who really know, and you have them try harder, and then you teach them that people tend to miss the biases here, and so have them see if they can fix it. And as the same guy said, quote, teaching psychology is mostly a waste of time. By Nobel Prize winning psychologist. Okay. Okay. Not in general, but in this regard. Okay, so I'm going to tell you the solution and about how it works, exactly what should be implemented, and I'm going to explain to you the answer to your question. Okay, so, yeah.
In the previous slide about the bias is likely, why would we expect a downward bias? Just that
we would.
So why?
We would expect some kind of bias.
Okay, and in this particular instance, we see a downward bias
That's
because
right.
they want to overestimate.
No, I haven't explained yet.
Okay. Great.
To build the suspense, and to really make sure that you're paying very close attention when I get to it. Okay. Okay. So now I'm going to tell you the answer, not to your question, because you're paying attention. I'm going to tell you the solution to the problem. And then I'm going to go back and I'm going to show you exactly where the problem came from. Okay. So how do you solve a problem like this? Actually, we know the cool thing about the social sciences is we have provided a solution to this problem. We know how to solve this problem. We can improve these forecasts. This solution applies in lots of different areas. Okay, so first of all, you remove human judgment where possible via formal statistical methods. You don't always do this because it's where possible, right? A lot of times you don't want a computer making decisions for you. But there's a lot of times you do, okay? And so when possible, you use formal statistics rather than qualitative judgment. You automate what can be automated, not what can't be automated, what can be automated. Otherwise, you take humans doing the wrong thing and you have computers doing the wrong thing. That's not a very good trade-off. The evidence for this is overwhelming. The revolution in data science, now called big data, which I love that term because that term, the media has latched onto it. They think they understand what we do. My mom thinks she understands what I do. She does, actually, but like the world understands. I mean, have you seen Moneyball? They wrote an entire movie about us just in the context of sports. They changed the names of some of the people, right? There are commercial models for this kind of thing. The Netflix challenge, where they had $1 million prize to see who could forecast which movies you would like better. Kaggle, Topcoder, X Prize, a bunch of these things. Okay, so that's the first one. Remove human judgment where possible. Second one is when you can't remove human judgment, institute formal structural procedures. Okay. So you have human judgment, you constrain the human judgment. You don't just let people say whatever they're going to say. You ask them, you elicit only the information that they're capable of providing. Humans have valuable information, you elicit that information from them. How do you do it? You focus the experts on what experts are expert at and not other things. If they have the information, that's what you're going to extract from them. There is evidence here from the revolution in social psychology. Double-blind experiments is an example of this. That's a procedure which we impose because people tend to bias things in their favor. Double-blind peer review, which I don't really like. I don't think it's a good idea, but I understand the reason for it, right? Peer review, right? If you really didn't know who the author was, and nowadays we do, but if you didn't know, then you're at least less likely to be biased by some little fact that you might learn by knowing the author's name. Violin competitions is just one of my favorite examples. So, violin competitions. Originally, men would win almost all violin competitions. This is like to get the job in the orchestra, which is like that. Like imagine you play the violin for a living. There aren't a lot of jobs. Okay, so in an orchestra, that's like it's like a real job. Like you're on a big important job. So they have all these competitions. Men would win. You'd have people listen and you say, I can't see why the men are really better than the woman. And so they had some psychologists work on this. And what they did is they instituted a formal structural procedure. They put the contestants behind a curtain and they had the judges sit there, but they couldn't see who the contestant was. Okay, so what happened? Turned out nothing happened. Still, the men won all the competitions. They couldn't figure out what happened. And finally they realized, okay, take your shoes off before you walk up there. So you can't hear the high heels. And then it was basically a tie. It was 50-50. Okay? So this is a great example, right, of something like social psychology understands this problem. You institute a formal structural procedure. You would actually, I missed the step in which the social psychologist told the judges, you guys are biased in favor of the men, okay? Make the decision that's the right one for the orchestra, but you were biased. Here's feedback. You were biased. Don't be biased. They were still biased, okay? So it's just, this is human nature, okay? So, but we can fix human nature, not by changing human nature, but by instituting formal structural procedures. Okay. Yeah. See, that was a pre-programmed funny line, but it's true. Okay. Third one is errors will still slip through numbers 1 and 2, and when they do, require transparency and data sharing so that we can fix things if they slip through. To bring the advantages of science, this is what science has learned, to government. The evidence is the revolution in data sharing in government and even in academia and even governments. To some extent, even industry is sharing data, which is quite amazing. And so we're going to use, I don't know if you can see, notice I colorized this. So we're going to take the revolutions in data science and watch here very closely. and social psychology. I worked hard on this, okay? And data sharing, okay? So we're going to have those 3 revolutions, and that's going to be the solution to the problem. And if you think about this, this is quite a generic situation. You can apply in lots of different situations. My proposal that the Social Security Administration use this should hardly be controversial, right? I have no doubt they eventually will. They're not going to do it today, but it'll happen. Okay. All right. So when would bias happen? Without these kind of protections, internal pressures make bias likely. So here's the explanation. Here's the answer to your question. Why biases, and why were the biases in this particular direction? So first of all, the stance of this office in the Social Security Administration is as the lone island of fairness. They're the ones that protect the Social Security Administration and the program from the heathens on the Republican side and the Democratic side. They're the only ones. They're the only ones that can be fair. Okay? So there's many extreme statements. The chief actuary is Steve Goss, actually, but I use the name Steve Goss to mean the office, basically. But he actually said, "I'll take a bullet before I modify anything under any kind of political pressure." And he says many things quite like that. I have no doubt he means it. I mean, I don't want to test that hypothesis, but and we agree. Remember, we interviewed a lot of people involved in this process, and we thought, we're political scientists. So the first thing you look for is political bias. Not true, okay? There's no evidence that this office is bending to political pressure. Moreover, the politics, but I'll get there. But the office acts as if it has a monopoly on fairness. They're the only ones with the data, after all. They let no one else score proposals, make forecasts, or decide what's to be evaluated. Several told us Goss, by which they mean the office, is intellectually biased or biased for the program, not politically biased. Okay? Like an incredible supporter of the program, and biased in that direction, but not politically biased for the Democrats or Republicans. There's a sort of consistency bias. They will intentionally degrade accuracy to maintain a central role in the political debate. And what does that mean? So if your forecasts are changing around all the time, then the politicians may not pay as much attention to you. If you say, this is my forecast, and when the Democrats and Republicans make a compromise, and you stay there, they pay attention to you. So they will push to keep their forecast constant. Even if they see the data going in a particular direction, they'll stay in the same place. They will intentionally bias today's forecast towards yesterday's, and the forecasts from this organization are much smoother over time as a result than other related forecasts. When the technical panel, which meets once every 4 years, recommends a change in some kind of parameter, if Goss has good evidence, he engages the panel and convinces them on the merits. If the panel has better evidence, he ignores the panel. If the panel has very strong evidence, so that it's just embarrassing for him to ignore them, then he adjusts the parameter, usually like about halfway in the direction that they want. And then he's got a whole bunch of other parameters. Remember I said there were 294 in that one example. And he adjusts some of the other parameters so it comes out the same way. So they cancel each other out. Many quotes such as this: the hard part is trying to balance the need to change on the basis of new ideas and understanding, and new data, which is what he means, with the desire for consistency and stability over time. Actually, that's not the hard part. That may be the hard part in the way he conceptualized it, but I would think the hard part would be making accurate forecasts, like not making this balance. They're explicitly making this balance, and the balance is leading to bias, but let me explain. So I haven't yet explained to you why the bias in a particular direction, but I want to give you a little bit more of them hunkering down and protecting themselves. So the technical panel are distinguished academics who come to Washington and spend good amount of time every 4 years. The process is OCSCT is extremely responsive in providing information to this group, as you can imagine. They're sort of judges of them. Steve Goss has a seat at every table when policy is made. But here's the methodological recommendations from the technical panel. There's almost no evidence of serious engagement. After each panel, for the last 15 years, OCSCT adopts a few recommendations, ignores many, does not come close to any kind of collaboration. Little progress is made on the most important issues, such as adopting formal statistical procedures, uncertainty estimates, transparency, data sharing, and routine systematic forecast evaluations, all of which the panels have recommended. The substantive recommendations of the technical panels, for some, there's just sort of token dismissals in the formal trustees report. The trustees report is where the forecasts come out every year. For others, the trustees report contradicts the panel, repeating the same words year after year without engaging the panel or the crucial issues raised. The trustees and the technical panel agree on lots of issues, but the lack of engagement is really obvious if you go read these reports. They're like 500 pages, so I don't immediately recommend it. But so let me give you an example. This is the estimates of, not estimates, but the guesses, the educated guesses of the ultimate rates of all-cause mortality decline. Okay, here's the vertical axis is the ultimate is the value of the parameter, which is basically how fast is mortality going to decline in year 26 through 26 plus 50, and the horizontal axis is the year. And in the first year, the trustees report said the parameter should be here. And then came the technical advisory panel, and it said, no, it should be here. And then the next year, which followed up on this, said, no, it should be here, because the blue is the actual trustees report. And it should be here, 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 here. That is, I'm going to ignore you, ignore you, ignore you, ignore you. Then came the next technical panel and said, hey, it should be here. And they said, no, actually, it should be here, 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 here. Next technical panel, hey, you guys. This is called not listening. It's like a graph. Like, we need this for our kids, right? Okay. I think you get this. Okay, so finally, what explains the bias? Okay. OCACT is vulnerable to bias, and it's unprotected because they haven't removed human judgment where possible, instituted formal structural procedures when judgment is required, and required data sharing and transparency. Politics have gotten much more intense and complicated since about 2000. In 2000, the Bush administration started to do what the Democrats called privatized Social Security, or attempt to do that. It's the first president to really propose a major structural change in the whole program. Social Security has been controversial from the beginning, all the way up to the president, but that was the first major set of attacks. This is not a story about the Republicans politicizing Social Security. The Democrats have plenty to blame as well. Politics, of course, in general have gotten more partisan. It's gotten especially more partisan over Social Security. We have lots of the stories in there. So what happened? The actuaries knew this partisan turmoil was happening. By the way, let me back up. So the Democrats and Republicans pushed for changes. So one thing that the conservatives is a better way to say it instead of Republicans, the conservatives would push the actuaries to say, there's a real problem. Tell them there's a problem. Tell them there's a problem so that they can say that it's a disaster and that we can negotiate and reduce benefits or something like that. The Democrats, they want to say, everything's okay. Let's just wait for a better negotiating partner. Okay, right? And so that's their current stance. This is not a uniform stance by any means, because within the party there's lots of debate. In the last presidential election, Obama and Romney completely agreed on Social Security. Both of them said Social Security is fine. And actually, literally the only thing that every expert agrees on, not the only thing, but they all agree that Social Security is going to go insolvent in probably 2030 or so. Like, no question, unless somebody does something. Okay, and Obama and Romney in I think the first debate both agreed, no problem, everything's fine. And they just made a deal, like, not to argue about this now. Okay, so it's not entirely. So the politics are not only incredibly partisan, but they're very chaotic. It's hard to predict their opinions. So what they do is they push the actuaries to come up with forecasts in a particular direction. The actuaries, trying to do a good job, are hunkering down, protecting themselves from the partisan battle. This is what we would want as American citizens. Okay? In the process, however, while they're pushing the partisans aside, they're hunkering down, they're keeping their forecasts unmoved because of the political pressure. They also insulated themselves from the facts. Some arguments are actually based upon fact. And facts do change. And facts are, or at least should be, inputs to the forecasting process. Especially since 2000, to a surprising degree since 2000, Americans started living unexpectedly longer lives. That's actually a good thing, okay? Due to statins and early cancer detection, et cetera, okay? So this is actually a good thing, okay? So here's just an example. So basically they're insulated from these facts, but let's just look at these examples. These are slopes, just as a way to describe it, these are slopes from a regression of log mortality on time from the previous 10 years. This is males and these are females. This grayed in or sort of tanned in area. The height here is the slope of mortality from the previous 10 years. What you see during this area is that mortality, the slope of mortality is unexpectedly large going down in all the male and all the female categories, if you see that. Okay. So that was a big change, demographically speaking, that would provide an input to the forecasts. And if people are going to live longer than expected, they're going to be drawing benefits longer than expected, and that's actually a problem. Okay? What happens if the Social Security Administration keeps their forecast constant when people are going to live longer than expected? They're going to convey that the trust fund is healthier than it really is. Right? I mean, people are healthier than expected, but the trust fund is less healthier than expected. Okay. So that's the explanation. Yeah.
So one thing I thought about when I saw this was that it'd be interesting to know that if you had continued those trends.
These trends?
Yeah, those trends. So in the before 2000s, if they hadn't had this improvement in health, and I know you can't know this because you don't have access to their algorithm, but like, how bad would the difference have been between?
Yeah, so I think there would have been some changes in the same direction. There was a big recession that surprised them. I mean, it surprised everybody. But there's been enough time since the recession for them to adjust, and they haven't adjusted.
Oh yeah, no, they're taking advantage. No, that's not the reason why I want to know. I want to know if they're just taking advantage of the situation, or they're doing more than that.
Oh, I see. No, I think what they're doing is just like not moving.
Okay.
They're just like staying still. I mean, a number of people told me Goss has all the parameters in his back pocket, and he has some that he knows should be higher, and he just keeps them in his back pocket. He has 5 of those that should be higher, and he waits until somebody has the goods as to why one of them should be lower, and he says, okay, I'll lower it, and then he pulls one of those out of his pocket in order to keep the forecast relatively constant. Like that quote that I gave, he really wants the forecast to be constant. They get a more central role in the debates. I think they're just hunkered down, trying to protect themselves like good public servants from the politicians, and at the same time they protect themselves from the facts. I think that's what happened. So, okay.
Does OMB and then the Congressional Budget Office provide scores ever for Social Security policy changes? And if so, I'm curious if you find patterns such that when Republicans are in charge of the CBO, more dire predictions come out, and when Democrats are in charge, more optimistic predictions come out. Same thing with OMB in the White House, in other words. So that might be one way to detect whether this actually is somewhat partisan, because I could see the story. I mean, you alluded to it somewhat about President George W. Bush coming in and really trying to pare back the program, and thus the SSA saying, hey, we need to make this out to look better than it is, or else we might see a real reduction to the program as we know it.
We haven't analyzed the forecast from OMB or CBO, but that would be a great thing to do. I mean, it's a good project. We're collecting some data relevant to it, but you should do that. Let me give you one page of conclusions. Okay, so the problem is informal forecasting methods lead to the potential for bias. Civil servants working hard to resist in this intense political pressure insulates them from the data as well. Non-transparency and little data sharing leads to no course corrections when the previous 2 things produce bias and the bias sneaks through and they can't course correct. There's systematically an increasing bias forecast since 2000. Without better procedures, you and I could not do better. That's really the important thing to notice, right? It's not the people. It's not like we have to fire somebody, okay? It's like we have to put in place better procedures. The solution is just to professionalize. It's to use like modern social science to improve government. To remove I'm going to say this a third time just so you all remember it. Remove human judgment where possible via formal statistical methods and the data science revolution. Institute formal structural procedures when human judgment is required via the social psychological revolution, and require transparency and data sharing to catch the errors that will inevitably slip through via the scientific revolution, we might call it. And there's more information there. So if you have more questions. Oh,
yeah. So the story that you're telling about how having the stability of the measure is the force field that allows the actuary and his staff to have a larger role at the policymaking table. That's super disturbing. It's compelling, it makes sense, it's super disturbing. But it seems like there could be at least a couple of different stories underpinning that. And one is that they really are, he or his staff are either power hungry or they're just path dependent and they really don't see what's going on and they've fooled themselves into believing what they're doing, and so they're giving them misguided cues when they go up to that policy table. There is, it seems, at least one alternative explanation, which is that they know that their forecasts are off, and or at least they have a sense that their forecasts are off, but they know that in order to continue to help guide policymakers, they have to have that stability because otherwise they would lose confidence and trust. And so I'm wondering if there's any of that second story, if not in the actuary himself, if in his staff.
I think it could be some of that. I think those are reasonable suggestions. I don't think that they could be completely fooling themselves. I mean, I think you can see that they're not forecasting well. I mean, you can see, you can just, like literally, like the statistical method we used was subtraction. That's a little bit of an exaggeration because the data are complicated and we have some nice graphs, but really, like there isn't much complicated in there. So they must know that they're making these mistakes. I'll layer on top of it one other speculation, which I heard when I went down to Washington when we went down to Washington to present this, that it's a perspective that I never even imagined was actually, like anybody would actually have this perspective. And I'm not saying that they all had this perspective, but I heard this as a legitimate view. And that is, rephrased in my like in-your-face way, it's good to lie to the American people because they might get upset that their program would be in danger. I mean, like, they didn't say it that way, but that was the meaning of what they said. And I was really taken aback. Like, I couldn't even believe that was actually a view. But let me rephrase it. Like, they're true believers in this program. As well they should be. This program had an enormous impact on people's lives and still has an enormous impact on people's lives. And one possibility, and some people claim is true, is that they just believe that they need to tell people it's going to be okay. And you know what? Congress will take care of it later. I think that if Congress wants to fix the coming insolvency problem, which it is a problem, it will happen. I mean, unless the economy does terrific or something, or people die earlier, which wouldn't be great anyway, but that's going to happen. If Congress decides to do something now, the changes, like, nobody's going to notice. It's not going to hurt you very much. We'll lengthen the retirement age. We'll increase taxes by a little bit. We have a lot of years until it's going to happen, so we wouldn't notice it that much. If we wait until just before the time when Social Security is going to go insolvent, then that's going to be catastrophic. So I think it's better to do it now. The partisans on both sides, they don't necessarily agree, of course, right? They could intervene when they want. They're making all kinds of complicated decisions about, political decisions, like, do I want to negotiate now with, they look at their negotiating partner and they say, maybe not, or maybe yes. But that may be some of it. Why do they want constancy? In part because they want to defend the program. I think that's not the way to defend the program, but, who knows?
I'm just wondering if you're presenting this to the actuarial people and these are your solutions, if a reaction might not be, well, there's a whole lot of politics and a whole lot of at stake in each one of those recommendations. I mean, remove human judgment where possible. Well, how and where? And wouldn't there be a huge argument about exactly how to do that? And if we release all this data, then the Heritage Foundation is going to get a hold of it, Brookings is going to get a hold of it, or liberals, you know. I mean, it's, you can almost see why they might have this kind of insular approach that you described, even in the face of some of these problems. So I just wondered if you thought about, in a sense, the politics of your non-political recommendations.
Yeah, that's right. I mean, if we were setting up a new system, I think we'd probably all agree to do it this way.
Yeah.
But they're in a particular system now, and to get from one equilibrium to the next, you know, I think if there's certain retirements that happen, I think it's much more likely to happen. But yeah, how you get from one to the next, you know, we haven't analyzed the politics. I mean, I've done a lot of things like this, and we've all done this like in our own departments to like try to get a policy proposal or a proposal through the department, right? You know, you figure out like how do you pitch it, what kind of features. I mean, this is like how. This is how a bill becomes a law, right? But how a bill really becomes a law, right? So we haven't analyzed that or tried to figure out the political path by which all the actors, you know, all of which have needs, and you know, I mean, the people there, they have jobs, like real jobs, like they have to keep their jobs. Like we have to recognize that, and we haven't analyzed the path and provided a way forward for that to happen. But you know, it seems undeniable that the forecasts are biased. They're systematically biased. They're biased in the same direction, and there's a better way to make forecasts. In politics, the facts are one of many considerations, and so you don't necessarily need to do this, but at some point it feels like they would do it. Joe.
You're making a case for these, like Goss and his office, that they're very committed to the organization. But if they're so committed to Social Security, don't they want to reduce the insolvency problem instead of exacerbate it? So wouldn't they have an interest, if they're really so loyal to the organization, to take into account more of the facts and to bring their forecast more in line with reality? Because they're just leading people to believe that the problem is not as bad as it is. So isn't there some personal component going on with them, personal career considerations as well?
Of course, I mean, of course there's
So
career considerations.
Incentives then?
Yeah, of course there's career considerations. I don't know what the right political answer is, okay? So the right political answer may be, no, let's wait. Let's assume everything's fine. Wait until the year before it's going to go insolvent, and then we'll have a big crisis. And this is a very popular program, and we'll just, you know, have this catastrophic change, but that's when you'll be able to get the other party, whichever one that is, to agree. That's it. You know, that's an argument. It's not a rational way to run a government, but you know, that's not the way. We don't run our government in a particularly rational way. So I don't know what the right political strategy is. You know. So,
I wonder how much political pressure there actually is on them to. This might not just be a case where, you know, their desire to have consistency aligns with the majority of the leaders in Congress and the presidency. Even though Bush was pushing for privatization, he also wanted to get tax cuts done and a bunch of other things.
That's right.
And the budget during this time, especially around 2000, becomes a huge issue. And they've passed all these rules that make it very difficult to fund programs or, you know, taxes. Without having offsets, and if this becomes, I mean, so there might have been not the same kind of political pressure that.
it could be. It could be. I mean, you know, the Clinton administration also, they were going to push for big changes in Social Security. Then the Monica Lewinsky scandal happened, and they backed off of it, and Clinton came out in favor of not changing anything. And then, you know, and then afterwards he just sort of never went back to it, right? But
And the Republicans also started making noises of, oh, Clinton and the Democrats are going to raise the retirement age. And that did not go very well.
Right. Although now, actually, the people that study retirement, one of whom I sat next to on the plane coming here, who said to me, I got to meet her. I mean, I got to start talking to her because she actually said to me, boy, Steve Goss is a pain. Who are you? So the people that study retirement, they call them. They say they study working longer now, because actually it's not so healthy to retire. Like to cut somebody's social ties, or quite a lot of their social ties, just at the time of life when you're probably least able to create them, it may not be a good thing. So that's an interesting problem too. We have this big program to help people do what maybe is not always the right thing. Depends on what type of job you have also. Our jobs are different than manual labor jobs, but yeah.
So I had 3 questions, of which one I agree with him. So I think there has to be a trade-off that we need to define to what extent SSA can share data. So what are the extents to which we can share, and there will always be certain kind of data that we cannot bring it to the public domain. So there we need to figure that out as well, I think, one. And the second thing is what has been the Statistical Bureau doing all this while? So
what has been the Statistical
the
Bureau?
Statistical Bureau of United States, I don't know, which is the highest body of statistical decisions of United States. So what has their role been throughout this period?
I'm not sure that group exists. I mean, there are groups in the United States government that you know, like the National Statistical Bureau or things like this, but nobody tells the Social Security folks what to do. Like there ought to be a group that, like, of methodological intelligentsia that goes around the government, and you know, I mean, we do this like in academia, right? Thou shalt not, right?
But there is no such formal ministry which looks after the statistical implementations in
There are. I forget what it's called. Does anybody know, like the Bureau of Labor Statistics and things like the Census Bureau? I mean, there's a lot of serious effort by very serious people that know a lot about this stuff. But I'm not sure there's a body that's responsible for all the statistical analysis that goes on in the government. I don't know that there's a higher authority.
Technically, like OMB has a lot of authority over different agencies, but it's not universal.
And is it budgetary authority, or is it actual procedural authority?
Procedural authority over any kind of data collection effort, like any kind of forecasting. I mean, all of it has to be usually approved by the OMB.
Oh, that's interesting. Really?
That's why I find it so.
So OMB needs to approve the Social Security Administration forecast?
No, that's why I'm finding this so incredibly surprising.
Oh,
is that
they
it
don't
doesn't
have
seem like it's the case for Social Security.
No, I don't think so. I think the Office of the Chief Actuary has some statutory independence, even from the Social Security Administration. So there was a time when when the head of the Social Security Administration was a Republican and was dissing on the Chief Actuary, and the Chief Actuary was saying, like, get lost, and because there's some sense in which the head of the Social Security Administration can't fire the Chief Actuary probably without cause or something. Oh, sorry.
Wait, sorry. Yeah, so and the third question that I had is about the technical part of it. So we have been talking about formalizing the statistical procedures, of which when going roughly through the paper, I could see that you have taken the Bayesian approach to estimate these. But then, like, continuing from that Bayesian framework, if we analyze it through dynamic linear models, which can be rational in this situation because it's time variant. Firstly, the model is time variant, so the dynamic linear model setup can exactly fit into it, firstly. And the second thing is, you just in your slides, one of your slides as well, you mentioned that smoking and obesity, there are these factors which have been dealt with in a qualitative manner and not in a quantitative manner. So dynamic linear model can take care of those parts as well. So why not use that, or just try to fit some kind of dynamic linear model into the data and see how that can help, because that goes pretty hand in hand with the Bayesian approach that you have taken. So
that might very well work. I'm really happy for technical questions, so thank you. So what we did was basically for each age, sex, cause, in our case, country group, there's a time series, and the time series goes maybe 10 or 20 years, and you want to forecast out like 25 more years. So if you had one of those, that would be lame. Like, you know, if you had 20 years of observations and you have to forecast out 25 years, it would be really horrible. But mortality data is such that if you have one of these groups, which is like 45-year-olds, And then you have another group, which is 46-year-olds, or 40 to 45-year-olds, and 46 to 50-year-olds. The two of them are highly related, right? And so what you could do is you could forecast one and forecast the other, but they're going to like go in different directions, right? Even with just a little bit of random error. And there's a lot of them, not only across ages, but across sexes. There's a relatively clear pattern, right? Better to be female than male in this respect. There's patterns in neighboring countries, like the rate of change in mortality in neighboring countries tends to be similar. There's a number of other things like that. And what we think of this when we do it in a Bayesian way is this is prior information. And so if you talk to a demographer, they'll look at a spreadsheet the size of this wall in very small print, and they're the kind of people that'll walk up and they'll say, this number is wrong. Like they, right? And they like deeply know the data. So, and they have an enormous amount of data because people are obsessed with death, right? And they've been collecting it for, literally 350 years of demographic data from around the world. And so what we did is try to formalize the notions that the expertise, not expertise, but formalize the patterns that they recognized in the data and put them into the model in the Bayesian framework.
There is no doubt that it has to be Bayesian approach, but then
yeah, so you could build on our model. That was the thing that we did, which we were really interested in. All this stuff as well, This is just what everyone else is interested in.
Thank you very much, Gary King. And we have a reception outside.
Thank you so much.